Hey everyone, and welcome. Today, we're jumping into one of the biggest, most fascinating questions in all of technology. What is artificial intelligence, really? We're going to cut right through all the hype, all the sci-fi stuff, and get to what AI actually means to the people who build it. You know, when we hear the term AI, most of our brains immediately go to something like this, right? A thinking, feeling robot straight out of a movie. But here's the funny thing. While we all have this clear image from pop culture, the actual scientific community has had a really tough time agreeing on what it even is. And that really is the heart of the problem. How in the world do you define intelligence in a machine when we're still trying to figure out our own? I mean, this was the exact question that the pioneers of AI were wrestling with, and it kicked off this incredible debate that shapes the entire field. So let's dive right in. This problem of definition, it's so much deeper than just picking the right words. It's about defining the fundamental goal of the entire field. What are we actually trying to build here? And as it turns out, there isn't just one answer. There are a bunch of competing ideas. What's really interesting is that you can break down this whole debate along two key questions, which gives us four completely different ways to think about AI. First, are we trying to build something that's like a human or something that's perfectly logical? And second, should we care about how it thinks or just about how it acts? And this simple little grid basically maps out the entire history of this debate. In the top left, you've got systems that try to think like humans with all our quirks and biases. Top right, systems that think with perfect, cold, hard logic. Then on the bottom row, we forget about thinking and just focus on doing. Should it act like a human or should it act in a perfectly optimal, rational way? Okay, so that first path, thinking humanly, man, this one is incredibly ambitious. We're talking about literally trying to reverse engineer the human brain. This is the world of cognitive science. But there's one huge roadblock. We don't have a complete theory of how our own minds work to begin with. So because that was so hard, a bunch of researchers basically said, okay, let's forget about what's happening inside the black box of the mind for a minute. Let's just focus on the output. Could we build a machine that acts so human that you literally can't tell it apart from a real person? And that simple shift led to one of the most famous ideas in AI history. And that, of course, is the legendary Turing test. The great Alan Turing came up with this back in 1950. It's a pretty simple imitation game. You have a human judge who's typing messages to two hidden players. One is a human, the other is a machine. If the judge can't consistently tell which is which, well, the machine passes the test. Now, to pull this off, a machine needs a pretty incredible set of skills. It has to understand language, obviously. It needs to store knowledge about the world. It has to be able to reason with that knowledge, and it has to learn as the conversation goes on. These aren't just random requirements. They're basically the foundational pillars of AI research even today. But the Turing test isn't the be-all and end-all. I mean, let's be honest, sometimes humans act in ways that aren't very intelligent, and we get fooled by simple chatbots all the time. But maybe the biggest criticism was that focusing so much on just imitating people was distracting the field from solving actual practical problems. So if imitating flawed humans isn't the perfect goal, this led some researchers to a totally different idea. What if we aim not for human thought, but for perfect thought? This is the thinking rationally approach, and it's all about using the pure, undeniable laws of logic. You've probably heard this one before, right? It's a classic syllogism, and it's perfect. If your starting points are true, logic guarantees that your conclusion is true. The problem? The real world is, messy. It's uncertain, and it is incredibly difficult to squeeze all that messiness into the rigid black and white rules of formal logic. And that challenge, that gap between perfect logic and the real world, leads us to the fourth and final box in our grid. And honestly, this is the one that changed everything. It's the idea that unlocked modern AI, and it powers pretty much everything you use today, the rational agent. So here it is, the big idea. A rational agent is simply something that acts to achieve the best possible outcome. That's it. It's not about thinking like a human or getting lost in pure logic. It's all about performance. It's about results. It's about making the optimal choice given the information it has. And this one idea is what shifted AI from a philosophical debate into a real engineering discipline. And this framework is just so powerful. For one thing, it's super general. You can apply it to any problem, from playing a game to driving a car. It's practical because it's focused on solving real problems. It's scientific because you can actually measure its performance. And maybe best of all, it cleverly sidesteps all those tricky philosophical questions about consciousness by focusing only on action. Okay, so if that's the goal, how do engineers actually go about designing a rational agent? Well, they use this brilliantly simple blueprint to figure out exactly what the AI is supposed to do. It's called the PS framework, which is just a handy acronym. Before they write a single line of code, designers figure out these four things. P is for performance measure. How do you define success? E is for environment. Where is this thing going to operate? A is for actuators. How can it actually do things in that environment? And S is for sensors. How does it see or perceive its world? And here's where that abstract idea becomes totally concrete. Let's take a self-driving car. What's its performance measure? Safety, speed, and efficiency. What's its environment? Well, that's the roads, the traffic, the weather. Its actuators? The steering wheel, the brakes, the accelerator. And its sensors? The cameras, the LiDAR, the GPS. All of a sudden, this incredibly complex problem is broken down into a clear engineering task. And this is exactly what that looks like in the wild. You can literally point to the S for sensors, the cameras and the spinning LiDAR on top that the car uses to perceive its E for environment, the road. All of it is designed to maximize its P for performance. This is the P's framework in the real world. So let's bring it all back home. This idea of the rational agent isn't some far-off futuristic concept. It is the core design philosophy behind the AI that's already woven into our daily lives. Every single one of these can be seen as a rational agent, a recommendation system on a streaming service. Its goal is to maximize your engagement. A financial AI trading stocks, its goal is to maximize returns. They all take in data through sensors, and they all take actions to get the best possible outcome. They are all built on that same PEAS framework. So I want to leave you with this thought. You now have the fundamental blueprint that engineers use to build AI. So if you look at the world through this new lens, this lens of rational agents, environments, and goals, what problem would you design an agent to solve?